Imagine we need to find the LCM of 126 and 168. First, let's build the numbers 126 and 168 using prime cards. The number 126 will be made of a card of 2, 2 cards of a 3, and a card of a 7. And what about 168? Correct! It will be made of 3 cards of 2, a card of a 3, and a card of a 7. Now, to find the LCM of 126 and 168, we will start with the number 126. Do you see the number 168 also in this number? No? What can we do to make this number include 168? Exactly! We need to attach 2 cards of 2. This new number contains both numbers without any extra cards. But what if we started with the number 168 instead? Exactly! We need to attach a card of 3 to include the number 126. Guess what? We end up with the same number. Both ways work, but starting with the number having more cards can sometimes make the process quicker because we might need to add fewer cards. Can you think of any other approach? Pause the video and think about it for a moment. Fantastic idea! Another approach could be to combine the number cards of 126 and 168. Is this a common multiple? Yes, it is. But is this the LCM of 126 and 168? Good observations. This is a common multiple, but not the LCM. But how do you know? Exactly. We can detach the extra card of 2, a card of 3, and a card of 7, leaving behind the smallest possible number that still contains both original numbers. Here is an interesting part. Do you know what the cards we detached represent? Exactly. They form the highest common factor, HCF, the common prime cards found in both original numbers. Now, let's look at another useful method. We can break each number into its prime cards. To find the LCM, we take every unique prime card and include it as many times as necessary to fully build both numbers. For example, to find the LCM of 126 and 168, we take 3 cards of 2, 2 cards of a 3, and a card of 7. Does this method match any method you learned earlier? Exactly. It is the same as finding the prime factors of each number, then multiplying the highest powers of each prime factor together. This method makes it quicker and simpler to find the LCM without listing lots of multiples. Now, pause the video and take a moment to compare these visual methods with the methods you already learned. Comment below which method helps you understand the concept better and in a simpler way. Now, here's another interesting pattern. What if one number is already a multiple of another? Let's consider 15 and 30. Since 30 is a multiple of 15, the LCM is simply 30. Why? Because the larger number already includes all the prime cards needed to build the smaller one. Since 30 contains all the cards to build 15, it's our LCM. Try finding another example like this. Here's an intriguing pattern. What happens with 2 consecutive numbers, like 8 and 9? Let's examine their prime cards. For 8, we have 3 cards of a 2. For 9, we have 2 cards of a 3. Notice that these cards are entirely different, there are no common factors. This means their structures don't overlap at all. To make a multiple that includes both 8 and 9, we need to attach all their prime cards. In other words, we multiply them. If we remove any card, it won't be a multiple of both 8 and 9. For example, if we detach a card of 2, it contains 9 but not 8. If we detach a card of 3, it contains 8 but not 9. To make a multiple of both, all cards are needed. Thus, the LCM of 8 and 9 is 72. This is why the LCM of 2 consecutive numbers is always their product. Try it with another pair. Want to test this out? Pick any 2 consecutive numbers and check for yourself. Do they ever have a common prime card? What is their LCM? Before we wrap up, here is a challenge for you. Can you find 2 numbers that have an LCM that is their product, but are not consecutive? Look carefully, there are plenty of examples. Drop your answers in the comments below. In this video, we have explored how to build multiples, find common multiples, and discover the LCM using the visual method. If you enjoyed this video, share it with friends, classmates, or even your math teacher. Let's keep discovering together. See you in the next video for more number patterns.